Alright, today we're working on section 3.2. We're going to be continuing our work with this section having to do with imaginary numbers. Remember that the square root of -1 is I, so that's going to be important when we're simplifying. Anytime we're trying to simplify something, we want to think of first as the square root of -1 is going to be the I, and then take the square root of the rest of it. On example 2 here, we're trying to solve this problem right here. We've got x squared plus 9 equals 0. Here's how we solve this. We're going to subtract 9 from both sides. We now have x squared equals -9. Remember, if I have an equation though, what do I have to put in plus in front of this when I have an equation? Plus or minus, right. So this solution is actually going to be x equals plus or minus 3i. We have to put plus or minus. See, look, if I wanted to check this and see if it worked, I would have to do -3i, square it, plus 9, and I'd want to see if that's 0. Well, what's -3 squared? 9. And so then I'd have 9, and then I'd have I squared. And so I squared is -1, so I'd have -9 plus 9. And that would again give me 0. So the -3i does work, and the positive 3i would work the same way, because positive 3 squared would give me 9 as well. Alright, looking at example 4, solving this one, we're going to try to get x squared by itself, so we're going to subtract 20 from both sides. So when we do that, we get x squared equals -20. When I take the square root of this, I'm going to get x equals plus or minus. Now simplifying this, we have to think of this as the square root of -1 times the square root of 4 times the square root of 5. So the square root of -1 is I. What's the square root of 4? So we're going to have plus or minus 2i, and then radical 5 we can't do anything with. So that would be the solution there. Any questions so far on solving? I want to show you what this would look like. If I just had, you don't need to follow along with this, just watch. If I have the equation y equals x squared minus 9, how does x squared minus 9 factor? X plus 3, x minus 3. So the x intercepts would be at 3 and -3. So watch how this looks if I graph it. See how these are going to be my solutions at 3 and -3? And now if I go to the other one, I'm going to have x squared plus 9. And watch how this one looks if I graph it. It's way up there. And see how there's no x-intercepts? That's the reason it has no real solutions. It has no x-intercepts. Alright, let's keep going. Looking over here now. We're going to solve these equations. So if I want to solve this equation right here, I've got to set equal to 0. How would I do it? Couldn't I take the 25 over here? So I'd have -25 equals 5x squared. Now what? Divide by 5. I'm just going to switch it around. I'd have x squared equals -5. And now to get x by itself, I'd have to take the square root of both sides. So I'd have x equals plus or minus. Anytime I have x squared equals, I have to put plus or minus. And then the square root of -1 is I, and then I would still have the 5 in there. Those would be the two solutions. So this does have two solutions. It's just that the two solutions that we get are imaginary solutions. Solving this problem now. What would we do first? Add 10. So we're going to have x squared equals negative 8. See if you can simplify that now and get these solutions. Anybody think they know? What do you think? Good. Ian's right. It's going to be 2i radical 2, and here's why. If I take the square root of both sides, this is now x. The square root of a negative is always going to be an I. I want to think of 8 as being 4 times 2. The square root of 4 is 2. So I'm going to have x equals plus or minus 2i radical 2. Any questions there? On number 16, it's always a good idea to eliminate fractions before you try to solve an equation. So what would be the common denominator for 3, 5, and 3? 15. So I'm going to multiply this whole equation by 15. When I multiply this term by 15, I'd have negative 15 divided by 3. That's negative 5. When I multiply this term, I'd have 1 times 15 is 15, divided by 5 is 3. When I multiply this one, I would have 15 divided by 3 is 5, times 4 is 20. So now to solve the problem, I want to get x squared on one side and the number on the other. So I'm going to subtract 20x squared. I get negative 25x squared equals 3. So I'm trying to get x squared by itself. I'm going to divide both sides by negative 25. So now I've got x squared equals negative 3 over 25. At this point, I'm going to take the square root of both sides. Do we know the square root of 3? Is there any perfect square root of 3? No. What's the square root of negative 1? I. So we're going to have x equals plus or minus I. Radical 3 we can't do anything with. But the 25 is also under the radical. And what's the square root of 25? 5. So these would be our two imaginary solutions. Notice on most of these quadratics we are getting two solutions. Okay? Let's look at number 17. Sketch a graph of a function that has two real zeros at negative 2 and 2. So if I want to have solutions at 2 and negative 2, that's the way it's going to look. So what kind of a shape would I want to have that would have those solutions? A parabola, right? Okay, so I can make my parabola. Maybe it's going to look like this. If I know that these are going to be my zeros, then I know that function has to be y equals x minus 2 for this one, and x minus negative 2 for this one. So what does that multiply out to be then? Multiply it out, FOIL it out. What do you get? X squared minus 4, good. So that's going to be the equation, that's going to be the function that has two real zeros at negative 2 and 2. Now sketch a graph on the same grid of a function that has two imaginary zeros of negative 2 and positive 2. How do you think I can take this equation and make a new equation that's similar to it that would have solutions of positive and negative 2i? What do you think, Allison? You're right. Because if I have x squared plus 4, then I'm going to have, if I set this equal to 0 to solve it, I would get x squared equals negative 4, take the square root. See how that does work? Plus or minus 2i. How does this graph look then, x squared plus 4? A parabola that's been what? Shifted up 4. So it would look like, I kind of ran out of room, but I'm just going to go right into this other problem. Look like that. Alright? So if we have real solutions, it has to cross the x-axis. These are the solutions. These are what make the function equal 0. But here, there are no values, no real values that will make this equal 0. The only values that will make this equal 0 are imaginary, and that's why we don't have any x-intercepts. Okay? Any questions? All right. So that's it for 3-2.